So we've looked a little bit at AFS, but we really haven't talked about what AFS really is. So let's talk about that. AFS started as part of the Andrew project at Carnegie Mellon University as a joint project with IBM. In the year 2000, IBM released the AFS source and it became OpenAFS. And now OpenAFS is managed by the OpenAFS Foundation. So AFS differs from other kinds of network file servers, such as NFS and SMB. With those, you can just export an existing directory on your computer, and it will appear as a network volume. OpenAFS requires that you add all your data to the network share through an AFS client, and you can't just export an existing store as an AFS volume. And also, you have anytime you want to be able to back up or restore things, you have to use AFS commands. The files that are actually on the AFS servers are really only useful to AFS commands. So there's two major components to AFS. There's a client and a server. Clients basically have a cache manager and some sort of kernel driver. And in Linux, there's actually a built-in AFS driver called KAFS or CAFS. Which several Linux distributions actually package and include by default. For servers, there are three major things that you'll see. There are file servers, volume servers, and database servers or protection servers. Let's start with the AFS client. So for the Linux AFS client, there is an AFSD service that runs, and it basically sets up the AFS mount point and talks to the OpenAFS servers. It requires a kernel module to be installed for it to operate, and usually this is either pre-built as a separate package or it uses something called DKMS to compile the kernel module every time you boot into a new kernel. There are macOS and Linux clients available as well, and you can find them on the OpenAFS website. However, you'll often find with modern operating systems it's very difficult to get these open source kernel modules running in macOS and in Windows due to the fact that they are fairly protective about running out of source, or I'm sorry, third party kernel drivers. Look at this. We are going to look at the AFS client. So Vagrant is running right now. Waiting for it to run. So I'm going to connect to the AFS client. So Vagrant, AFS client. So we can see that AFS is mounted. So there's a service. So I'm going to run system control status OpenAFS. OpenAFS client.service. Now this is the OpenAFS client daemon running AFSD. So it's user vice etc AFSD. The path to this executable depends on the distribution. This is a CentOS 7 system, so it's using this condition. Now the user vice, that is actually a historical artifact. Whenever OpenAFS, or rather, when AFS was first written as part of the Andrew project, it was called Vice. So everything was under user vice. So there is a process running right now that is called AFSD, and also if you look, grab OpenAFS. There is an OpenAFS kernel module as well, and it is installed there, and it is actually installed as part of the DKMS OpenAFS package. So it actually is using DKMS to compile and install the kernel module every single time there's a new kernel. So it creates this mount point, but how's it configured? Well, let's go to that directory, user vice etc. So this is where a bunch of configuration files are for this version of OpenAFS. There is a file called this cell, and it basically is what the name of this cell is. So in this example, it's using test.example.com. There's a couple other files in here that start with cellservdb. A cellservdb is the way that OpenAFS keeps track of all the various OpenAFS cells that it can talk to around the world. Actually, some of them aren't even OpenAFS. There are other OpenAFS software that they can connect to. There's also a way to talk to an OpenAFS cell using DNS records, and we'll get into that later. But in this case, there are three files. And actually, the important one is the cellservdb. That's the only one that's read by the AFS client. The other two, the .dist file, that's actually packaged with the OpenAFS package. And the .local is anything that is not part of the .dist. And the .dist, let's take a look at that real quick. Cellservdb.dist. You can see all these different AFS cells. And what happens is the first line here with the little greater than sign, that is the cell name and a comment describing what it is. And then these two other IPs underneath it are the database servers for the cell. And it basically tells the client how to talk to the cell. So you can see there's here something from Austria. There's some other ones here. It's alphabetical, so of course we're going to see a bunch of Austrians and Czech ones at the top. There's actually going to be no OpenAFS out. Oh yeah, I'm sorry, it's grand.central.org. That is the, oh yeah, it's the first line. That is the public cell for OpenAFS, Grand Central. And so it's actually possible, you look at /AFS, you don't see it. The way that we have AFS configured on here, just to make it less confusing, is it doesn't actually create the mount points for those cells by default. But if you go to lsafs grand.central.org, wait for it, it actually exists, and now there is a directory for Grand Central. And it did that by looking it up in the cellservdb. So why are these three files? Well, like I said, there's this .dist file that's packaged. That is something that's actually has a list of known AFS cells. But what is this cellservdb.local? Well, that's actually this local cell, and you can see it's using a local network. That's because it's running in Vagrant and it's not published widely. And so as part of the startup process of the OpenAFS client, it actually concatenates the .dist file and the .local file into the cellservdb. So that's kind of how that works. And there's one more file I'd like to look at, and that's cache info. And that basically says where AFS is mounted, so you can see /AFS, and then where the AFS cache is, which is user vice cache, and then the size of the cache, and that is 5,000. So we've talked a little bit about a cache and a cache manager. We in OpenAFS, you typically call the AFSD the cache manager, because what it does is it acts as an intermediary between the AFS servers and your user interacting with AFS. And there's basically files as they are accessed in AFS get cached locally. And it gets a little complicated as to how those files are cached. It breaks them up into blocks. But the important thing to think about is that whenever you're actually reading a file in AFS, you're actually interacting with a file that's local, or at least it's cached locally. So interactions with files in AFS can actually be pretty fast once it's been cached locally. This is actually something that gives AFS a really big performance gain that you don't see in other network file systems that aren't cached. So I think this is probably a good place to stop with the AFS client, and next we'll talk about the AFS server. So for the file servers, first there's the file server, which obviously serves the files. It's called file server. However, most modern OpenAFS systems use something called DA file server, which is a demand attached file server. And the difference between those are that the file server would um, basically attach to every single volume it was aware of, and the DA file server will only attach to a volume whenever it is in use. And we'll get into why that's an important distinction later on. There's also a volume server and the PT server, and let's take a look at that right now. So we're looking at the AFS servers now. I'm going to connect to AFS server 1. So Vagrant SSH AFS server 1. So if we look here, we can see AFS isn't actually mounted on this system. So it doesn't actually see the AFS server. I'm sorry, it doesn't actually talk to the AFS through a client. Everything is running as a server. So let's look at the system D service for the AFS server. System control status OpenAFS server dot service. You can see there's a bunch of processes running. And actually, what happens, you'll see one of them is boss server. And so OpenAFS and AFS in general actually predates a lot of these process or init servers like systemd, and it has its own process that it uses to start and stop service called boss. So we can interact with that by going boss status AFS server 1, and you can see, yep, it's running. And because I didn't do anything, add any extra flags, it's running unauthenticated. But it'll tell you it's running a PT server, a VL server, and a DA file server. And DA file server, as we mentioned earlier, is the demand attached file server. So it's running a protection server, a volume server, and a file server. This is actually pretty common, but it's not very helpful. Let's take a look at the long output, because what that is it'll actually give you a little bit more information about how long it's been running, what process or what command it's actually running, and whether it's running or not. And you can see that some of them have been restarted in this particular instance. Also underneath the DAFS, you can see that there's actually 4 processes running underneath there. And the reason why it's running there is because the file server has this built-in thing to do file system or to do volume salvaging. And as I talked about earlier, the demand attached server only attaches to things that have been in use. And the reason why this is that with sites that have thousands and thousands of volumes, if a server were to crash, whenever it needed to restart, it would have to salvage every single one of those attached volumes. And attached volumes can take a long time, or I'm sorry, salvaging a volume can take a really long time. So one of the things that was developed was this demand attached file server, and when it runs, it will only attach a volume whenever it's accessed. And this means that if it were to crash, the file servers, whenever it comes up, it would only need to salvage anything that was in use, and it's significantly faster to boot. And keep in mind, OpenAFS has been running on systems for the last 30 years, and a lot of these servers that were running were not particularly fast, and the storage has not been particularly fast, and so making this sort of speed increase is incredibly important for modern hardware as well as historical hardware. This is actually something that is still not widely used in some institutions. So this is kind of a nice thing to be able to see in a modern implementation. So how are these files configured, or these services configured? Well, you can see they all run out of user AFS. So let's go into user AFS. And you can see there is an etc directory there. Let's go into that. And in this directory, this is the configuration file for an AFS server. And you can see there's a self-serve-db, and you remember that from the client, but it is actually a much smaller self-serve-db. It just has the local configured cell. Now this isn't the one used by the client. This is specific for servers. Also, you can see there's another, this cell. Tells it what cell it's running. This is actually pretty simple stuff here. The other files you see in here, the key file and rxk data.key tab, those are actually the Kerberos keys used to set up the service. And fortunately for you, you didn't have to deal with any of these things whenever you were setting up your AFS cell. The Ansible job created them and put them in the right place. So we don't really need to get into a huge amount of details, but what I will do is I will run the Kerberos command to look at that key tab. So if I go klist -kt rxkd, remember that command. Oh, no klist. I guess I don't have that installed on the server here. But basically, it is an AFS specific key. And the last file to look at is user list. Let's take a look at that. Just Vagrant admin. So what this file is it keeps track of who the AFS admins are for the AFS server. And so you can see vagrant.admin is in there. This is just how it's configured by default, so it's not too unexpected. So let's go back up a directory. Let's see, there's this local directory. What's in here? Oh, I don't have the ability to look in that. So I'm just going to use sudo local. See, this is where a lot of the state is stored for AFS servers. So if I go to sudo cat boss config, this is actually the config file for that boss command that I saw before. So boss status AFS server 1. What that does is boss talks to the boss server command, and then the boss command is running those various, or the boss server runs those various daemons underneath it, and you can see how it's configured from there. There's also a sysid file in there that's important for starting up AFS, but it is also something that's automatically generated by the thing. So this is just kind of a general how does it work kind of setup. And so there's a couple other files in here. There's bin. Bin is where all the executables are, and logs, obviously, where the logs are. And the DB is where, let's go DB. That's basically where the protection database keeps its database. So that's all state used from running the AFS server. So we know that there's actually 3 AFS servers running on here. So if I go boss status AFS server 2, I can actually see that there's an AFS server 3, and I can see them all from here. That's actually a service that Boss lets you talk to over the remotely. Okay, so we've looked at AFS clients and AFS servers. Now you have a little better idea of the various processes that are running. That's all for today. I suggest you poke around a little bit more. That's the whole point of this thing, is for you to investigate and have a better understanding of how OpenAFS works. So take a look at your Vagrant setup cell and try looking at the service or looking at some of the files under there. And so that's all for today. I'll see you next time.